Hello everyone, my name is Patrick Boelens and I am the author of the Shape Drivers Asset. And in this video I just want to go and sort of give you a quick look at what this asset does and what it's capable of. Now I won't be getting into too much detail about how it does things and how it works. For that I'd like to refer you to my manual, which is linked up in the description below if you're watching this on YouTube, or in the description above if you're watching this on the Unity Asset Store page. So in this scene I have a modified version of Sintel Lite by Ben Dancy with several mesh objects in it. And one of the mesh objects here is called Body. And Body has a bunch of blend shapes attached to it. And blend shapes are just shapes, which you may know as shape keys or morph targets if you're familiar with other 3D software. And it's just a value between 0 and 100 that drives a particular shape. So if we set this to 100, you can see she's having a big smile, and if we set it to 0, and it's gone. Now Unity has had this functionality for a while, but there hasn't really been an easy way to drive these shapes unless you're either setting them in Inspector, which isn't very dynamic or useful in most cases, or if you're setting them through script, which not everyone is a coder and can take a lot of time. So what this asset does is it allows you to control these shapes based on a variety of inputs on the controlling object. And what I mean by that is, let's go to the armature, shoulder, and select the upper arm here. Go to our rotation tool, and as I rotate this, you can see that the armpit sort of folds inwards way too much, and we even get some intersection with the shirt there. And this is a case where you might want to have a corrective shape key. And something that was very important for me in making the choice of how to implement this was, well, what if you have an animation and then you want this upper arm to be the responsible party for determining whether or not that shape should be driven. So on this responsible object, the upper arm.l, I'm going to add a shape driver component. I'm then going to select the body, which is the mesh that has the corrective shape key, and select the correct shape key, which it already has, its armpit correction.l. Then I'm going to add a driver term, which is basically the piece that really sort of defines the value. And you can add multiple of these and combine them in several ways. You can add the value, multiply the value, and this way you can create sort of complex hierarchies. But for now, let's keep things simple. Just set it to rotation. And because it's an arm and only really rotates along one axis, let's set it to single axis to get the best results. Now I'm going to rotate this arm to say, well, this should be about max probably. I'm going to click this nifty little button and it's going to set the end rotation. Oops, I forgot one thing. I need to set the channel to be the Z axis, or Z for you British folks. Reclick, and now the end rotation is about 43.6 degrees. I'm going to go ahead and reset my transform component to the default T-pose, and I'm going to set that to the start rotation. Now this won't execute in editor mode, so I need to hit play first. But now when I rotate this arm, you should see that the armpit doesn't fold in and stays in place. And we no longer have any intersection with the shirt. So very cool, dynamically driven, even works with animations, and really helps produce nice, clean animation results. Now let's take a look at something a little different. Here I have, again, the Sintel head, and I have a couple of controllers, one for the eye shapes and one for the mouth shapes. And if we take a look at them, you can see I have quite a couple of shape drivers, one for each of these shapes. And they are all distance based. They are measuring the distance between the controlling object, which is the green or blue sphere here, and the red target objects. Now if I hit play, and next time I'm just going to go ahead and full screen this as I have it following my mouse, you can see that the distance to each shape drives that shape's influence. And what's really cool about this sort of setup is you can blend smoothly between expressions. So because you are gaining influence in one, you are automatically losing it in one or two others. And so if I stay around the edge, you get very strong pronounced emotions, and if I stick a little closer to the center, you can see they're sort of more subtle and a little less defined. Lastly, I want to go ahead and real quick show you a bounded control, which is cool for the simple reason that it uses two driver terms in one shape driver. So first, let me show you what's happening here. Actually, let me turn this over to mSmile. If I hit play, the mouth shape is now determined by the height of this controller sphere. So not happy, very happy, which is all fine and good. But now I only want this to happen when I am in between these red bars. And the second I get outside of them, boom, it resets to 0, no matter where I am. And the way this is done is by using two different driver terms, as I said. So the first samples the Y position, very straightforward. Then the second one measures the X position, and it starts at negative 0.2, which is the position of this left red bar, and ends at positive 0.2, which is the right position. And once it gets outside that, if we take a look at this curve, it drops real dramatically. So because of the clamp mode, everything to the left of this will have a value of 0, and everything to the right of this also have a value of 0. So this value is always only ever going to be either 0 or 1, and that value is going to be multiplied by this resulting value. So no matter where you are on the Y, multiplying by 0 always gives 0. Now there is one final thing that I want to show you, because some of you may be watching this and thinking, well, that's great, but I want to have just a little bit more control, which for that I have a script callback option. So let's say that this is a time neutral script, and somehow this manages time, or it does something with your world clock. I'm going to add a shape driver real quick, and let's drive the mesh shape on the body again. I'm going to set the type to be a script callback, and because the responsibility lies with the object, well, responsible, you only get access to that object's components, which in this case is time neutral. And what this needs to be is a function that returns a float, which I've added. It's called getSignTime, if you want to take a quick look at it. Here it is. All it does is it returns the sign of current time multiplied by a public speed. So getting back to it, the starting value of any sine wave is -1 and the end value is +1. If we go here and hit play, you should see a mesh shape in our mouth sort of coming and going in a sine wave pattern. Now the cool part about this is that it's absolutely fully dynamic, just like with the animation parameters or with the transform parameters. You can adjust the speed here in this component, and immediately you can see the results down there. So right now it's pretty much non-existent. It's very, very slowly. You can see in the inspector that the values actually are decreasing, or we can make it very, very fast. And with that, I will end this video. Thank you very much for watching. If you have any questions, comments, or concerns about this asset, please do let me know, and I'll try to get back to you ASAP. Thanks again, and have a great day.